Hi everyone, so I'm going to show you today how to use this little tool that we've created for you for steady-state heat transfer in a composite wall. I'll just run you through some of the variables in it, and then I'll show you a couple of test cases, and then you can go along and actually play around with it yourself and actually use it to help you figure out some of your tutorial questions as well. So we've got our composite wall up here on the left, and it's currently showing us a three-layered structure that has these three materials currently selected in them. So they're all on sliders, and you can alter each of these materials. So we have brick, concrete, and plaster that you can use as an external material. But just note that for brick, they generally come in discrete sizes. So you don't have a slider bar for your brick, but it will generally come in about 100 mil discrete sizes for brick. And so you can select across your installation, your internal. You can alter to concrete or brick as well, and then plaster and concrete on the interior surface. So before you go through and you calculate anything, we first want to look at our resistor network that we have. So this describes our steady state case, and that is our combined surface thermal resistance, and then the thermal resistances for each of the materials that we have in our composite wall. We also have our Q solar gain as well, our radiative thermal resistance to the sky, and our radiative thermal resistance to the exterior ambient temperature, so T out, which you can alter up here in the top right. So almost all variables you can alter, except for the T sky temperature. One important thing to note in this thermal resistance network is that we have one set, which is just our wall construction, which is a series thermal resistance, and then we have our parallel thermal resistances for everything that's exterior to our building, so our radiation and our convection that's in contact with that surface, that exterior surface. So we have conduction moving through just our wall construction. So let's go through one test case for you. I'm going to leave the area of the wall to 10. The only thing that's going to change for your particular simulations are the magnitude of heat transfer, so you can see that changing here in these values that are going in and out of your building. So you can see the magnitudes changing. Alright, so I'm going to fix that to 10 for now, leave that. And we're going to work on a test case of, let's say, 42 degrees exterior temperature, so it's an extremely hot day in Sydney. That's very uncommon. Say one of the hottest days in summer. 40 degrees, and let's say we want our interior temperature of our building to be somewhere around 25 if we want to maintain thermal comfort. So we have that interior temperature here, it's 25 degrees. Alright, so let's set up, I want plaster on my interior surface. Let's go for a standard wall. Standard house, plaster on the interior surface. We've got a little bit of insulation. Oh, sorry. Yeah, we'll pick insulation. We've got a little bit of insulation in between. And then we have brick on the exterior, about 100 mils of brick on the exterior, so it's a brick veneer. Alright, so after you've set your parameters, you have to click the calculate button in order to calculate what the temperatures are at each point along your wall. And you can go and play through your various temperatures if you wanted to alter the temperatures, and just click calculate again. And just have a look at how that affects the temperatures that are moving from the exterior to the interior of your building across these materials. Okay, I hope this was helpful, and I hope that you can use this to assist you in answering your tutorial questions.